Okay, so this is the first lecture in a series of mathematics I've been wanting to work on for a while, and I don't really want to call it a specific topic. I just want to call it college, because it's college level, college mathematics. And there's a couple of things I want to introduce with this, what this series is about and how it works. And the idea behind no specific title is that it's intended to be watched from this lecture on. Because I'm a firm believer that mathematics is sequential. It's sequential. And a lot of the problems that people have with math is that they learn topic 1, okay, and then they go on and learn topic 2, okay, and then say they miss topics 4 through 6, and they get to topic 7, and they have no idea what's going on because they don't truly understand 4 through 6, or they never really mastered 4 through 6. So they need to go back and relearn topics 4 through 6, which is fine, because, I mean, not everybody has different brains. People struggle with different things. Some people struggle with calculus, some people struggle with algebra, some people struggle with formulas, some people struggle with computation. And that's okay. They just need to focus more on one specific subject. And that's fine, just to study. And that's kind of what the purpose of this is. So that, for instance, if you're watching, even if you're just watching a TV series on TV, just a general regular TV series, and say the main character comes back from the dead, and you'd be really shocked that the main character came back from the dead because you missed the episode where he died. Same thing with math. If you don't know what's going on in topics 4 through 6, topic 7 might be a little bit hard. So the whole idea on this is that we start with this lecture right here, and we move on from there. So this lecture is going to be the beginning of this, and from here on out, everything related in number 2, you would first need to learn topic 1. And everything in topic 3 is based on from topic 2, and it's continued and continued and continued. And yes, I'm going to put in the description kind of what I cover in the topics, but the name of the lecture is going to be and then this one should be part 1. This is part 1, and we're going to go on to part 2, and so on and so on and so on. Another thing I want to focus on is that I think these lectures I'm going to try to make 10 minutes long. Between 10 and 20. So if I'm in the middle of something and my 10-minute timer goes off, and I'm not just going to be like, okay, 3 plus 4 is beep, 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 beep. Okay, we'll see you next time. And then the next time I'm going to start with 7. That's not going to work like that, okay? I'm just trying to get these to where that each topic is 10 minutes long so that you don't sit here and have to watch 50 minutes of me going on and on and on in front of this sliding board. I want it to be 10 minutes and then stop and then take a break and then you can review or do some problems. I want problems with this. I'm not going to post them publicly. I would like you, if you need problems with this, you can message me on Facebook. That's fine. Or email me. Excuse me. Email me. That's perfectly fine. But 10 minutes is about as long as I want each topic to be. And with that, let's start with the first topic. And the first topic we're going to talk about here is fundamentals. Fundamentals of algebra. Fundamentals of algebra. And I don't want to call this lecture Fundamentals of Algebra, but the first few lectures are going to be about the fundamentals of algebra. And without algebra, there would be no algebra without addition, subtraction, multiplication and division. I want to list them all up on the board, but I'm not going to go over how to, this lecture isn't going to be about how to add, but I think it's important that you recognize what addition is and some words that are common with addition. Same with subtraction, multiplication, and division, and some of their basic properties. Okay, so let's start with addition. I'll leave a multiplication over there so I don't have to watch over there. Addition is the sum of two numbers. And when I do this, there's some notations that I want to add, and we really haven't talked about some of the fundamental objects in algebra yet. Objects meaning numbers. But I want to say that A and B, when I talk about numbers, A and B are real numbers. And for now, we're going to talk about what real numbers are in the future. But for now, I just want you to understand that these numbers are numbers that you use on a daily basis, A and B. And A and B are variables. And when I talk about the sum of two numbers, I'm talking about, in algebra, we notice this as A plus B. Okay? A plus B is the sum of two numbers. Subtraction, which is often termed as the inverse, the opposite of addition, is the difference. The difference of two numbers. And we write this using our symbols as A minus B, where A and B are numbers. Now, the third operation is multiplication. And multiplication, some of the notation that we use in algebra, a lot of people get tricky with multiplication. And multiplication is the product. We recognize this as the product of two numbers. But some of you may already know that there are more than just A cross B. And cross, this is something that we really don't like to use. Very few mathematicians use this notation today. So I'm going to put a little cross through A cross B. You often see when you use real numbers, when you use numbers, this will be okay, 3 times 2. But when you use variables, this is not acceptable because X and cross are usually misunderstood for each other. Which I could get to the next one that is definitely used. A, B, if they're next to each other, like this, in a sentence, this means A times B. And a lot of the times, this dot is used a lot in multiplication to indicate multiplication, A dot B. So we can't write 3, 2, right? Because that would be 32. But we could write 3, 2 in parentheses, just like we could write A, B, or we could write A, B, or we could also write A, B. Okay, all of these indicate multiplication. So two variables next to each other, A dot B and parentheses, all indicate multiplication. It's all a way of writing multiplication. And the fourth operation will conclude this video. And there's an exception to the rule here with division. And I want to explain why before I get into the notation of division. Because a lot of people don't struggle with the notations of division, although there are several of them. The division is the quotient. The quotient is the key word for division. The quotient of two numbers. But we can't use all A and B if if we say A divided by B, we have to indicate that B cannot be 0. B cannot be 0. B is never 0. And here's why. Okay. So we define, and you may remember this, multiplication of by 0. We define multiplication by 0 that any number, and we're going to use A and B here, and this represents any number times 0. Any number times 0 is always 0. So if I was to create an instance where I was dividing a number by 0, if this was possible, if this equaled some number B, okay? If I multiplied both sides, whatever you do to one side of an equation, it remains equal on the other side of the equation. It's like one of those old balance scales. If you took things off, you would have to take things off the other side in order to keep it balanced. So whatever I do to one side of the equation, I have to do to the other side of the equation. So if I multiply this side of the equation by 0, I have to multiply this side of the equation by 0. And then I would have A is equal to B times 0. Well, this is what we call a contradiction. This is not possible because we define any number times 0 to be 0. And here I'm saying that this number times 0 is some number A. And it could be any number because I didn't define what A is. So this is just not possible. This is why division by 0. Division by 0 is not possible. Division by 0 is not possible. And this is why. So let's talk about, real quick, I'm going to conclude with how we denote division. So we can say that, I already said that A divided by B, and in this case, B is not equal to 0. I'm going to go ahead and write that up there so I don't have to write it 100 times over here. This is A divided by B. And it took me a while to really understand where this symbol comes from. This symbol is like a mini fraction. This is also division. This is commonly used. This is commonly used more than this, but this notation is used. And A/B is also used to denote division. And this concludes part 1. Thank you for watching.